Good evening, this is Mr. Wintermelon, and if the purpose of your visit is to learn about diffusion and osmosis, I am sorry to disappoint you because this will be the worst video you can watch to learn about diffusion and osmosis, because I'm not going to talk about them. This video is something like a foreplay to the topic of diffusion and osmosis, because I'm going to talk about something that will make people wet. Specifically, water, and what happens when you add sugar into water. I'm sure many of you have experienced this in your daily life, which is adding sugar into water. Let me add some more. So, if we take a look, we can see some sugar is still inside, but eventually they will sort of disappear. So, what does it mean when something disappeared in water? The simple answer will be the substance dissolve. But what does it mean by dissolve? Simple answer will be because we cannot see the substance anymore, that means it dissolves. So does dissolving means we cannot see the substance anymore, means that the substance is dissolved? So what I have down here is a jar. Then I have a glass of water. So let me put the glass of water into the jar. Now, can you see the glass anymore? Did the glass just dissolve because we cannot see the glass anymore? So clearly, dissolve is not so simple. What is the science behind something when the substance dissolves? So the question is, what happens to a substance when it is dissolved? How come we can no longer see its particle anymore? Where did the particle went to? Did a black hole came over and suck it up into another dimension? To help explain this observation, I have this simulation down here. The first example I'm going to discuss is the case of sodium chloride, which is your normal table salt. Sodium chloride is an ionic compound, and the small pink color sphere is used to represent sodium, while the larger green color sphere is used to represent chloride. So right now, sodium chloride is chilling in its solid form, or in the form of salt crystal, better known to you as salt grain, which you should have seen it if you have done some cooking. And you might observe that sodium is joined or bonded to chloride. And it's not just one sodium is bonded to one chloride, it's the whole chunk of them. Many sodium is bonded to many chloride. And because there are so many of them, they form a crystal that is large enough for us to observe with our naked eyes. So right now, what I'm going to do is to add in some water. Observe carefully what happened to the salt crystal. So as I add in water, you can see that the water caused the sodium as well as the chloride to separate into sodium ion as well as chloride ion. So as I add in more water, the concentration actually decreased because the solution became more diluted. So what is happening down here? So when a substance dissolves, or when an ionic substance dissolves, the water will separate the compound into individual ion. And because ion is so small in the size of atoms, we can no longer see it with our naked eyes. So this simulation is only showing sodium as well as chloride ion. I will add in the water molecules to help you better understand what is going on. In the simulation down here, water molecules is represented by this red and white color sphere. The red color sphere is the oxygen molecules, while the smaller white color sphere is the hydrogen molecules. I'm going to add in a salt particle. Observe carefully what happens. So immediately when I add in the salt particle, the water molecules will start to surround the sodium ion as well as the chloride ion, separating or dissociating them, causing them to dissolve. So the question on your mind might be, why does the water molecules do this? As all of us know, sodium is positively charged while chloride is negatively charged. And so it turns out that water molecules are partially charged. So water molecules actually have a negatively charged end at the oxygen side, while a positively charged end at its hydrogen side. So the negatively charged end will be attracted to the sodium ion surrounding it, while the positively charged end of the water molecules will be surrounding the chloride ion that is negatively charged. So this is what happens when an ionic compound such as sodium chloride is dissolved in water. The water will dissociate them into individual ion, and because individual ion is so small, that's why we cannot see them anymore. So this is the case of ionic compound. Let us take a look at covalent compound. So I'm going to reset the whole simulation, and instead of using sodium chloride, I'm going to use sucrose. Sucrose is actually your common sugar that you can purchase from any grocery store. 1 molecule of sucrose is made up of 12 carbon, 22 hydrogen, as well as 11 oxygen molecules. But of course, one single sucrose molecule is still too small for us to see with our naked eyes. However, as you can see, just now I pour many sucrose molecules down. Many of these molecules together will form sugar crystal or your sucrose crystal that is large enough for us to see with our naked eyes. So observe carefully what happens when I add in water. See if you can notice any difference when sucrose dissolve compared to when sodium chloride dissolve. So as I add in water, the same things happen. The water will separate sucrose. But now, instead of separating sucrose into individual ion, right? Water actually separates the sucrose crystal into individual molecules. So this is the difference between covalent compound as well as ionic compound when they are dissolved in water. So let me add in salt for comparison. You can see that for ionic compound, water molecules actually separate them out into individual ion. While for the case of sucrose, which is a covalent compound, water separates it out into individual molecules. But as I have mentioned, individual molecules is still too small for us to observe with our naked eyes, which is why when any substance dissolves, we cannot see them with our eyes anymore. So let me just go to this simulation and we will see for the case of sugar molecules. So let me add in sugar. You can see that water molecules will also separate the sugar into individual molecules. So in summary, What happens when a substance dissolves is water molecules will surround the ion or molecules, causing the ion to dissociate or causing the molecules to separate from one another. And because individual ions as well as individual molecules is too small for us to see with our naked eyes, that's why they quote unquote disappeared.